Nuestra siguiente invitada es la profesora Teresa Mattina, también es directora del Departamento de Genética Médica de la Universidad de Catania, Italia, y como habéis visto en la presentación anterior, ha estado muy involucrada desde siempre en Jacobsen. Va a hablar sobre las recomendaciones de seguimiento médico.
Hello, everybody. Thank you for inviting me here. I want to start with the last sentence from Paul's slide. He had $2 million, which is not too much. I had no money at all. And so you can understand why my work is slower. I always have been working with people having money. Some of my work, my cytogenetics work and array analysis has been done by Professor Zuffardi in Pavia, and she did it for free because she liked the subject. And before I go to pension, I would like to write everything I have in my files and give my support to this. But the only money I have had in the past was money to travel to go to polls or to European conferences. Now I don't have even that. But let's go on. I have had support from my students. The first you see is Katie, that Paul mentioned. The other ones have, are MD, some got PhD also in Jacobsen. Graziana Cassisi has done PhD. On the bottom you can see Christina, she is here, and the other two are also involved in 11q deletion at home. And there will be a girl from Naples who will be specializing in genetics, medical genetics, and she asked to join us and do some research on 11q. So I have support from my students. My first cases are 1993, the first case. I think somebody of you must know already because I may have showed this slide. First case, it was a large deletion. Second case, this is Giuseppe Bucolo when he was a child. He has a medium-sized deletion. And this is in 1996, had the smallest deletion that could be seen on cytogenetics. And once I had these three cases, I thought I knew everything about Jacobsen syndrome. The first case, Cecilia, also had a mother with a fragile site, and I also had a second family with fragile sites that Chris Jones studied for me, and we published the relation between fragile site and deletion. I have seen no paper doing the same molecular work to assess fragile site in publications. So I think this is a topic that has not been fully studied. This is the publication by Laura Penny, because I was collaborating with her first 17 cases. My 3 cases are the yellow ones in this slide, and they show the phenotype-genotype relation. It looked clear, straightforward. And then Chris found also that there might be more fragile sites on chromosome 11. Then we know what are the topics, the main features, the incidence. And now we know, I'm going to be practical now. We can have a prenatal diagnosis or a postnatal diagnosis, and the way the diagnosis is performed may be different. The older cases are analyzed by traditional karyotype, maybe fish if they are made a bit later. The best one have array, but they can have a CGH array or a SNP array. And then there is the possibility to have NGS, is next generation sequencing, analyzing the whole genome or all exome or all chromosome 11. Traditional karyotype, if you have a child who has been assessed by traditional karyotype, you must know that only big deletions can be seen this way. The deletion must be as big as at least 5 megabase, but 5 megabase cannot be seen by eye on a microscope. And most of the genes are missing. There are limits. The missing portion must be large. The breakpoint is not defined. And small deletion, interstitial deletion, are not detectable. Besides that, besides the deletion, there could be some other abnormality in the same child, and is not detected. If we add fish, we know more because we can see the missing part, if it's just missing, or if there is something in addition that is not from chromosome 11. And we also can see the parental karyotype, if it's normal, if there is a deletion with a translocation. CGH array is a comparative genomic analysis where the patient's DNA is analyzed as compared with normal genome, and it tells you exactly what is missing. It tells you exactly if there is anything more missing or if there is anything in addition, but only tells you unbalanced. SNP array gives you detection of all unbalanced conditions, if there is a deletion, a duplication, the precise breakpoint, but also tells you if the deletion is due to a paternal or a maternal break, because you can see what is missing. And also tells you if there are regions of homozygosity that are regions at risk for a recessive disorder. So it gives you more information. I prefer SNP array to CGH array. Tells you this is a homozygous region. So if you have a patient and the abnormality is detected by karyotype, you want to have array. But if you have array, you want to have also karyotype. I see some patients have been assessed by array who don't have karyotype analysis that gives further information, can give you more information about mosaics and if there are translocations. With array, you have breakpoints, and you can spot additional arrangements. I'm sorry for my English. My Spanish is worse. Parents needs to be analyzed. They are usually normal, but there are a number of conditions that could have. In one parent, you could see same deletion. As you know, there are mothers with a child or fathers with a child with the same deletion. Same deletion in mosaic, a fragile site. This is not studied at all, and I'm available to do that if we had money. Balanced translocation. Another balanced rearrangement, such as an inversion within chromosome 11, that is difficult to spot, is impossible to see by a ray because it's balanced. All these conditions can give us a recurrence risk. The recurrence risk, the chance to have another child with the same condition is low, but could be increased because a parent may have some condition that is not detected. Let's see mosaic. Mosaic means that parents, here I wrote a female karyotype because it is more frequent, is a female with normal cells and some cells with a deletion of chromosome 11. Mosaic is not always possible to find. If you take blood, let's say, and you get these cells, you would see the normal cells and the abnormal. But if you do the same person in another time or another tissue, or maybe later or from another part of the body, you may get only normal or only abnormal cells, and you would miss the mosaic. So mosaic can never be ruled out in any of us. The fragile site. What is the fragile site? It's a repetition of CGG triplets, which all we have a repetition about 11 is the number of CGG repeats. People who have a fragile site have 80 or more of these triplets. And if you do cytogenetics work, as for other fragile sites, which is a chromosome analysis made using low folate medium, you wouldn't see the fragile site. So this is going to be missed if you study with just cytogenetics. When the fragile site determine a breakage, the chromosome loses pieces of DNA until it makes a telomere, a new telomere. So if the patient has the parents have a fragile site, the child may have different sizes of deletion. You cannot say that one deletion is given by a fragile site. A fragile site can give different amounts of deletion because it depends on how long the chromosome takes to have a heel on the break. When the telomere is made, the chromosome is stable and can go to be fertilized, can be part of a karyotype. Reciprocal translocation is balanced. The array is normal. So this must be seen by karyotype. Standard karyotype with fish is easier. This is a translocation. And what happens if one parent is normal and the other has a balanced translocation? They join. The normal gives only normal chromosomes. The person with the balance, now this is a male for the pair condition. I made a male with a balanced translocation. He can give normal chromosomes, can give the two abnormal chromosomes, would give balanced, because what is missing from here is there, and vice versa. But he can have unbalanced chromosomes. And so what happens is the child could be normal, balanced, or unbalanced. This could be a Jacobsen syndrome, and this bit is not chromosome 11, it's a bit of another chromosome. So this couple can have normal, balanced, and unbalanced children. The array would be abnormal only in this case, and the parents would look normal on arrays. So even if array is the most advanced technique, it's not suitable to analyze parents. Traditional karyotype is necessary with fish. Now we have 206 11q children. Most of them have terminal deletion, some interstitial deletion. We have done follow-up of some of them. I have 23 years experience in some patients with a number of evaluation between 2 and 15 in some patients. And these are 40 patients with Jacobsen who have had a follow-up. And why follow-up? Follow-up is necessary to see what happens in the life of a child with this condition, and to update the results, the genetics information we have, and to update what's going wrong in the clinical findings. So what is, from genetics, the expression of the genetics into the phenotype? That is not only due to deletion of chromosome 11. My methods have been the cheapest one, the ones that don't cost anything. Is clinical evaluation, interviews and questionnaires, photos, scans that have been made by Peter Hammond, collection of files and documents, and genetics test. When I compare findings in the clinical aspects, I want to have arrays. I want to know the exact breakpoint. But I will not throw away the ones who have had only chromosomes. I will use as much as I can. The questionnaire gives me most informations, but remember that the questionnaire are given at the conferences, are given by media, and are received by persons who have not the most severe conditions. So we miss a population of Jacobsen that have the most severe condition because they wouldn't fill in the questionnaire, wouldn't come to the conferences. So when we saw the breakpoints, we thought there were some breakpoints that maybe they were the same, but this is chromosome 11. This is what is still present and what is missing. So this is the smallest deletion. This is the widest deletion. But if we analyze in detail this breakpoint, sometimes we find that they have the same breakpoint, exactly the same breakpoint. Sometimes it appears to be the same, but if we do more details of the break, it's different. And this may be a key to understand that a missing gene or a gene that is retained may make the difference between two children that have apparently the same deletion. So if we go into detail of array CGH, we can find equal or differences. Family history. Usually in one family there is only one case, but there are cases of recurrences. And what are they? Both the parents are normal chromosomes. This is the rule, but sometimes one parent is also affected. One parent is mosaic, as I told you. One parent is a balanced translocation, one parent has a fragile site. And also there is a rescue of monosomy that has been reported twice. So parents look normal, but in these two cases, the mother had the deletion repaired in her own. It was a rescue of monosomy. She had monosomy, the Jacobsen syndrome, but it was repaired, and the children, 2 children have had Jacobsen syndrome because the break was again there. So there are conditions that are difficult to spot, and we must understand that this is why when a family has had a Jacobsen syndrome, prenatal diagnosis cannot be refused for a second pregnancy. So if parents have normal chromosomes, the recurrence risk is low. If one parent is affected, the recurrence risk is 50%. If one parent is mosaic, we cannot say what is the recurrence risk. If the mother is a balanced translocation, the risk is 10–20%. If the father has balanced translocation, is slightly less. When a parent is a fragile site, we don't know what is the risk. Rescue of monosomy is just reported, but is not being studied. Ideally, then, the affected person should have SNP array and traditional karyotype with FISH, and I hope Paul will be able to find money for this, NGS, studying the normal chromosome 11, the whole exome, and possibly the whole genome. Parents should have a traditional karyotype and FISH, a search for mosaicism, and a search for fragile site, but this is only on research basis. Now, what's going on in pregnancy? Usually they are at term, but they may be preterm or severely preterm. About a half have normal pregnancies, but there could be all these problems, reduced growth, prenatal growth, threatened abortion or premature labor, placental abnormality, polyamnios, high blood pressure in the mother. Investigations. In the olden days, it was very difficult to identify Jacobsen syndrome in prenatal test. But now that ultrasound scan are, you can have a 3D ultrasound scan combined with arrays in the prenatal amnio, you will have a diagnosis. And the risk is in this, that you find small deletion, you cannot say what the phenotype would be. There are VUS, abnormality with deletion of chromosomes that are not always associated with abnormal findings. And in this case, it may be difficult to say to the families what kind of child they are going to have, what will be abnormal. And also with non-invasive prenatal screening, there may be diagnosis. Delivery is difficult with cesarean section 33% and breech 11% of cases. At birth, again, remember, many severe cases are not included in this because they are lost. Children have, almost all children, 86% have problems, heart problems. Very severe are not here. Respiratory distress or other respiratory problems, low platelets and severe anemia, bleeding or petechia, vomiting, feeding difficulties, jaundice. In the childhood, we would notice intellectual disability, autism, delayed milestones, physical developmental delay, recurrent infections, problems with immunity. I want to say I expected Virgil to be here, so I didn't say much about immunity. But I think we should do the same as for bleeding. We must pretend every child with Jacobsen has an immunity problem, even if it's not diagnosed. So we expect everybody has a problem with immunity, even if the doctors say no. Endocrine can have problems with pituitary or thyroid. Genitalia, in most male children have problems with genitalia. Other organs, such as kidney and epilepsy. In the adults, we see scoliosis, obesity, joint contracture, and problem with dealing with sex. Clinical aspect, mental, physical, face, other clinical features, organ malformation. Why do we study the phenotype? Because the phenotype is what worries us. If a patient had a lesion with no phenotype, we wouldn't care. But we can find findings that are expected in Jacobsen, and there are cases where there are unexpected findings. These children need additional attention, but they are also the most interesting to be studied because they can give further information on Jacobsen syndrome. We know the height is short, below the third centile. We had difficulties making curves. We were preparing special curves, growth curves for Jacobsen children. We need to have curves to see if they are below the expected or above the expected. But it's very difficult to make curves in a population that is made of children of different racial origins. They have different expected height, even normal, children of the same. And besides that, some children get hormones, and so the parameter may be changed by this. Head is generally large. If it's small, please notice that. I will go faster, Sixto. If the head is large, MRI, it may be needed craniotomy. MRI is also important if the head is small, because it is very unusual to have microcephaly in Jacobsen. So if somebody has microcephaly, we must see why. Let's jump this. We have done a thorough clinical checkup, and we can see that some patients, these are the widest, and these are the smallest deletions. You can see that the phenotype is very variable. This has not a small deletion, this has not a small deletion, but you wouldn't be able to say that there is anything abnormal in the face of these children. This is my Italian patient with the smallest deletion. She has everything of Jacobsen. Has kidney problems, heart problems, the face, and this has much a smaller deletion than that. So we want to know what makes the difference. This is a family reported in the literature, 3 generations. The face is Jacobsen, mildly affected, but they have no intellectual disability. And this is the reconstruction by Peter Hammond. I think he put together faces of Jacobsen. Maybe we should split the narrow faces and the wide faces to emphasize the phenotype. let's forget about this. Remember, unusual findings give attention. Skin is due to infections, immune reaction, unusual immune reaction. Vascular problems, they may be dilatation, but also stenosis. We collected information from 171 patients who had surgeries, 308 surgeries. And this is the reason why I collected this information is to know if there are unfavorable events and complication and recurrence. But I think these are under-evaluated. So I think this is very interesting to do in more details. If anybody wants, I will send you more questions, because this is important. Most children, 75% of children have surgeries, and it's very important to say how frequent it is to have need of blood, problems with infections, problem with the anesthesia, and recurrence. At any age, thorough checkup of the patient with blood test, endocrine study, immunological assessment, X-ray if necessary. In neonatal period, intensive care for the cardiac malformation, feeding difficulties, vomiting, craniotomy may be needed. Blood tests, they may mimic a more severe form of anemia, leukemia, Fanconi's anemia, but there is no need for bone marrow biopsy if you know that it's a Jacobsen. And eyes, surgery may be necessary for strabismus and for ptosis, because they may help the child work. Strabismus may go to blindness of one eye. Ptosis may be difficult for the child to walk, but surgery may have relapse. So at follow-up, the scheduled clinical evaluation, growth, neuro-behavior evaluation, cardiac, ophthalmological, audiological, dermatological, endocrine, immunity, and NGS. NGS, this is the future. I hope we can do it. This is my last slide. I'm sorry for my English. It's getting worse and worse over the years.